Hey everybody, MS Farzan here, and welcome back to this video series on how to create a 2D multiplayer tabletop card game using Unity and Mirror. In the previous episode, we looked at how to set up Mirror for our multiplayer project, and we're going to continue in this video to flesh out the architecture for our game even more. So the first thing that we will want to consider is that within our network manager, which I've clicked here, we have a registered spawnable prefabs list, which I mentioned are where we need to register every type of game object or prefab that we want the network to be able to spawn across the network. So let's add a few fields here. And for my money, there are a few things that we probably want to add here. We want to be able to add card 1 and card 2 in this registered spawnable prefabs, so that when we ask the server to create some cards for us, it's able to do so. But we come up with an error which says at the bottom that says prefab card 1 cannot be added as spawnable as it doesn't have a network identity. That's a good reminder that every game object or prefab that we want to appear on the network or be spawnable across the network needs to have a network identity attached to it. And if we want to be able to manipulate the transform, it also needs to have a network transform. So for each of these different game objects, I'm going to add a network transform. And what that does is it automatically adds a network identity to it, which is great. And in this case, this specific case, I want the card 1 to have client authority, meaning the client is able to own the game object at a certain point. It's able to manipulate it and move it around. So I'll do that for card 1. I'll do that for card 2. Remember, I add a network transform that automatically creates a network identity for me. Make sure client authority is checked. And then let's say I want my drop zone also to be governed by the server, spawnable by the server, and I don't need the client to have authority over this one. Same with the enemy area. I add a network transform. I don't want players to just be moving around the transforms of the enemy area. Nor do I want them to be able to do that with the player area, but I do need a network transform attached to that. So I've done that for all of these different game objects. Go back to my network manager and I drag my card 1 into this first slot or anywhere. Card 2, drop zone, enemy area, player area, and then let's also add our button here. Let's say that the server should be able to add the button for us. So we add a network transform to the button, and then we don't need the client to have authority either. We can click the button as a client, but we don't need it to have authority over the button. Okay, and then what did I do? Oh, I forgot to drag this to the network manager. Here we go. Okay, so now each of these game objects or prefabs are now spawnable by the network, which is great. So let's go back to our player manager, which you might remember is going to represent the player for our game. And just think through, well, what kind of things would a player need to do? If you look at some of the tutorials on like the Mirror website or elsewhere, you might see that there is a physical player that this is a digital player that this is attached to, like a sprite that goes and like pews things and needs to be able to take damage or increase health or whatever. We don't quite have that scenario, but we still can take that mindset when creating our player manager script. Let's say the player manager is the one that wants to be able to govern what happens when a card is dropped, or when to flip a card, or when to deal cards, how to keep our deck intact for our cards. So let's just add a component here, and let's just call it a new script, and we'll call it player manager .cs. And we'll go to our assets root directory, find that script, and then just move it to our scripts folder. Okay, I'm going to open the player manager script. And just wait until Visual Studio opens here. And here it opened on another screen for me. And okay, so in this empty, just opening up my cheat sheet here on my other screen. In this empty script here, we need to change a couple of things, and we're going to need to do this for any script that requires networking. The first thing right at the top here with our declarations, let me close this Solution Explorer. At the top of our declarations, we also need to add a line that says using mirror. That just allows us to benefit from the scripts that already, the classes that already exist within the mirror namespace. And then this public class player manager and any script that is going to require networking, rather than deriving from the standard mono behavior, it needs to derive from network behavior. And if you have the Unity Tools workload installed for Visual Studio like I do here, you'll get some autocompletes here, which is really nice. Okay, so let's start here by thinking, okay, well, we want our player manager to, at the very basic, handle our card decks as well as the ability to deal cards. Right now, that happens in our draw cards script, which when somebody clicks on it, they get this, we run this for loop, and it does it for us. That works just fine in our single player scene, but in our multiplayer scene, we actually need the server to handle it for us, so that when I draw cards, you're able to see them, and I'm able to see them, and vice versa. So what we're going to do here is we're going to move a lot of this code over into our player manager script. So let's start here. We're going to delete the start and update for now, and we're going to start by writing, similar to our other script, public game object card1 and public game object card2. Okay, and then while we're here, although we won't use them just yet, let's also use the public game object, create a public game object player area, public game object enemy area, and public game object drop zone. Now, right off the bat, we know that from experience that when we go to our player manager game object, which has the player manager script attached to it, these game objects have been exposed in the inspector. So I'm going to drag and drop card 1 here and card 2 here, right along their fields. But I'm going to leave player area, enemy area, and drop zone empty because I won't know which ones they are until the game starts. Remember, the game is going to create the player area and the enemy area and the drop zone in my scene when it starts. So I need to find them at runtime, or I should say that might be a way of handling things in your scene. That's not necessarily the way that you need to do it, but and specifically, I've received some comments about, well, why do you find the player area, enemy area, and drop zone using GameObject.find, which is what we're about to do? It's very expensive in terms of system resources. I really haven't seen it make that much of a difference, as I mentioned in a previous video, in terms of the impact or the footprint it has on your system resources. Maybe in a resource heavy game, you might see some difference here, but I just haven't noticed any appreciable difference in performance. So I wouldn't worry about it too much. And then right at below all this, we're going to create a private list based on game object that takes the type game object. We'll just call it cards, and we'll say it's a new list, and this will represent our card deck to draw from. And this is, if you haven't created a list before, this is just the syntax to do so. Okay, so if you've used Unity before, you might say, okay, I'm going to use the start method to find the player area and enemy area and drop zone. That's a good way to do it. When the game object becomes alive, go ahead and find those things that I've told you about. We don't really want to do that here because we're going to presume that with the host-client relationship that we talked about in the previous video, this player manager is going to operate both as our server and as our client. And we want to think that when a client or a version, a build of the game that discovers the server or is able to connect with the server, when it starts playing the game, it's going to have a bunch of things that already exist in its scene that are totally different from another client somewhere else that it's about to play. So if I look at my scene, and we'll call me client A, I'm going to have all this stuff on my scene: the enemy area, the draw cards button, the player area, the background, the drop zone, in my client. You're going to have the same in client B on your client. So what we want to say here is public, not that at all, public override void on start client, and then this is where we're going to put that information. If you haven't dealt with override methods, please do take a look at the C# documentation. You can look at it on Microsoft's website, for example, or just Google override methods. Essentially, that means that there is a base level or a base version of this method, and we're overriding it to add some functionality. We start with our base method, and then we say, also do this other thing: player area equals gameObject.find player area. Enemy area equals gameObject.find enemy area, and drop zone equals gameObject.find drop zone. And make sure your spelling matches and spacing matches perfectly what you see here in the scene. Now it strikes me as writing this that I've created this template or this version so many times that there may be some artifacting in that, like the way that I do things here. You may not actually need to do this, and you might be able to just drag these to these fields. As I mentioned, there's a previous video that I made where we talked about in the drag drop video, for example, finding the drop zone. That's been obviated by the way that I do things now. So I do apologize in advance if there's some artifacting here that isn't totally necessary, but I will assure you that the game works and is more or less clean if you look at the template for it. Anyway, it's good to know how to do things. Okay, and then now that we know how to do that and find our stuff, we also want to add our cards after the game starts to this card list. Again, we could do that in the start method in a single player game, but in our multiplayer game, we need to do a little bit more work. We want the server to handle this for us, and one of the things that is going to help one of the things that's going to help with is like cheating. I don't want the clients themselves to determine which cards they get. I want the server somewhere in the cloud somewhere to determine that, to help prevent or avoid each client A, like me, being able to cheat against client B. So I'll write public override void on start server. And here we just want to say cards.add card1 and oh, I see. We named this card and not cards. Cards.add card2. So add these two cards to the these two game objects to the cards list, which takes types of takes a type game object. If you wanted to, you could, and I highly recommend doing this early and often, you could debug log cards to make sure that this is working. You don't need to do that with this video because I can just tell you that it's working. We'll see that it's working. But if you run into any issue throughout this process, I highly recommend just logging to the debugger something about what you're doing, and you'll be happy to see that it works, or unhappy to see that it doesn't work, but happy that you get a new problem to solve. So in any case, that's one thing to keep in mind. And one other note about this, that when the server starts, I want to do this thing, and something that I need to do here, whenever I use a method that the server is going to run exclusively, I need to use the header server here, right preceding the method. Okay, great. So you know what the heck? Live a little, right? We'll debug log cards just to give us something to do. Okay, and now I will wait for it to compile, hit play. Oops, I hit play twice. And now we see, I don't see anything on the screen because Network Manager is handling everything for me. I do see the background, and now I see all this this business, which tells me that actually, hey, maybe we did do it right, and you do have to find them at runtime. So that's great. So I guess Bob's your uncle there. We'll click on, we'll play as the host, and then go to our console. We hit draw cards, and what do you know? Nothing happens, nothing logs to the console because we haven't attached anything. So right now, all of our code is still attached to the, still included in the draw cards script. So let's port the rest of that over. Let's just say, oh, but it should have logged to the debugger the cards. So let's just check on that. Oh, actually, yeah, it did. It logged the list. Cool. Oh yeah, so it did work. Great. Okay, great. So now let's go back to our draw card script and see that we have this onClick method. Let's just copy this. Go to our player manager, and we'll paste it here for now, although we're not going to be using that in its exact format. And we'll delete everything in between the curly braces here. We still need the onClick because we want, when the player clicks on it, we still need it to work for us. And we'll delete everything else in the script. And we need to add at the top of our script, just as we did with the player manager, we need to add a using statement, using mirror, and make sure that it derives from network behavior. Okay, here's where things get a little bit hairy, but we'll get used to it. So at the top of our script, we need to declare a public player manager. So out there in the world somewhere, there's going to be a public player manager script, and we're just going to call it player manager. And when somebody clicks on this button, we want to locate the player manager that's in this client that has been created by the network for us. And we're going to request the server through the player manager to do something for us. The way that we're going to do this is we're going to say network identity, which you recall is the component attached to a game object that's networkable. Network identity, just a, you could name this whatever you want. We're going to make that equal to network client dot connection dot identity. This basically says I'm looking for a network identity that is governed by the network client that is being used right in this game scene. And the player manager that we talked about earlier is equal to network identity dot get component player manager. And then we're going to write something really funny here. It's going to say player manager dot cmd deal cards. And we'll figure out why in just a moment. Okay, so why are we doing this? Let's think this through. When I, as client A, click on this draw cards button, I want to send a message to the server to deal me some cards. At this point, when the game is running, there will be a player manager in my scene. Where's our player manager? And it has a script attached to it that will have a method. Right now it just says onClick that is going to do some work for us, basically create some cards. The way that I find that player manager that's in my scene and make sure that I'm finding the player manager that's local to my client is by finding the network identity, which we say is the network client. If I hover over this is a network client class used by the networking system. It contains a network connection that is used to connect to a network server. So, and you can read up on what this network client does in the documentation. But in this network identity, attached to it is a component, and attached to that component, and that component, one of its components is our player manager that we're looking for. So that's a long way of saying that by writing this little code block, I'm able to access the player manager class that we're creating right here. And we've told it to run the method cmd deal cards. This doesn't exist just yet. Right now we have a public void onClick. We're going to change this to be called public void cmd deal cards, just like the draw card script says. So the squiggly lines went away. We haven't done enough here though. We have, what we've done without knowing it is written what's called a command. And this is a really good point for us to talk about communication via servers and clients. You might recall from the previous video that a host is a game or a build of the game that works both as a server and a client, whereas a client is just something that has access to client functions. In mirror terminology, in terms of communications, there are two basic ways of communicating between the server and the client. The first one is called a command. A command is when a client makes a request for the server to do something. The opposite of a command is called a remote procedure call, or an RPC. That's when a server tells a client or all clients to do things. In this case, we've created a command, which, like this server header up here, we need to write within brackets command right before a method, a command method. And the beginning of the command method has to start with the letters CMD, or uppercase C, lowercase md. That's just the way that Mirror does things. Whenever you write a command, you have to have this command header, and whatever the name of the method is, it has to begin with CMD. We'll see something similar with our remote procedure calls. So within our command deal cards, we can keep this for loop, and we'll say GameObject.card instantiate. Right now we just have card 1. We're just going to change this to cards, and then random.range parentheses 0 comma cards dot count. Okay, this just means that we this is like a shorthand for saying that we want to randomize which card we want to come out of our cards deck, our cards list. That's the way that we write that. So we want to instantiate a random card from the cards list. And then rather than saying card.transform set parent, we need to reconfigure this, and I'll show you why in just a moment. So after we've done this, now we've created the card in our scene, but now we want the server to spawn it so that all clients can see it. Right now, only my client would be able to see this card. So we say network server dot spawn card comma connection to client. What does any of this mean? I understand, and I did mention that the learning curve might feel a little bit steep at this point, but we'll keep walking through these different components, and I think that you'll get it after doing this for a little bit and trying it in different scenarios. So after we instantiate the card in our game scene, our local game scene, or I should say, after the client requests the server through this command to instantiate a game object, we want it also to spawn it across the network so that all clients will be able to make use of it in some way. And this second parameter that we pass in here is connection to client. This is important because we could just say network spawn card, but we say connection to client, meaning that we want the client that called this method, this command, we want it to have authority over the game object. We want it to own the game object. We'll talk about what that means in just a moment. And I recognize that we're dealing with a lot right up front, but we will benefit from it later. Okay. Now we had this part of the code here that we want to set the parent of the card to the player area. Let's run this right now and see if this is actually up and running, or if we need to do more work here. We certainly will need to do more work in terms of the networking aspect of it. So we hit play. We'll play as a host. We'll draw the cards, and yeah, they appear right here. I see that it has randomized the cards. I see one pink card or a magenta card and a bunch of blue cards here. I can drag and drop as normal, so it works here. The thing that won't happen is that if I have another client, they're not going to see any of this because all of this is just happening locally. I need to instruct my game to replicate what's happening on every client. And so let's just take a brief moment to look at how the magic is going to work. Right now I'm going to go to File and say Build Settings, and then make sure that in this build, right now I'm working on a PC, so I'm going to be building it to the PC platform. I don't really need to mess with anything here. I just want to make sure that my scene, right now called sample scene, is included in the build. And I'm going to hit Build and Run. Then I need to choose a directory. I'm going to create a new folder. Let's just call it Builds. And I'll choose that directory to tell Unity where to build my game when it's ready to be run. And I want to build it right now because I need 2 builds of the game to run this game. You if you have 4 players in your game, you might need 4 builds to run at the same time. And this will get pretty onerous after a while. So I'll show you in a later video how to use a tool called Parallel Sync to have multiple versions of the game running at the same time without having to do this every time. But right now, that's just kind of like a shortcut. So I have one version of this game that is running as a build. I'm going to go back to the Unity editor and hit play. Let's say that I'm going to be client A. I'm going to work as the host. And now you're going to be the client. I'm going to click on client. You're client B. So I'm the host, meaning I'm the server and client A. And then you'll be just client B. You hit draw cards, and nothing happens here on your side of things. And then I see something on my side. I see a card here. And I hit draw cards, and then I draw like a bunch of cards. So it's just like basically a hot mess. Like we haven't figured out we haven't set up the logic here for it to make sense. So I'm just going to hit Alt F4 to close this build. And I know that it has accessed the server because it's running correctly as a client, but we're not working properly here. So let's dig back into our code. Here I'm going to delete this line. Even though it's kind of working on the client side for me, but not for you. And what I'm going to do is I'm going to create a remote procedure call. And this, you'll recall from just a few moments ago that a remote procedure call is a thing the server tells clients to do. So the way I start this is I need to write a header that says client RPC. And then underneath it, I'm going to create a private void RPC show card. Remember, it has to begin with the letters RPC. And this RPC show card is going to take a game object card and a string type. And we'll need to distinguish in our code the difference between when a card is dealt or when it's played. And we're going to compact everything into this one client RPC to make it really nice, neat, and clean. And we're going to say if type is equal to dealt. Well, let's do something here. And else if type equals played, do something else. So we could say if the type is equal to dealt, then go ahead and set it to the player area. But we have a problem here. If we just copied and pasted the code that we used before here in between the curly braces of the for loop, then when client A deal cards, it's going to show up in my player area. But then when you do that, it's also going to show up in my player area. So I need to distinguish between what happens when I click it versus when you click it. And this is where authority comes into the picture. When in this code up here, when I say that spawn the card and make the authority be governed by the connection to the client, that's basically says if I as client A clicked the button to draw cards, give me authority over the card, which means that only I should be able to manipulate it in this very specific use case scenario. If you as client B click that button, make you have authority over that card or all 5 of these cards. And the way we check for that is using a Boolean called has authority. That's what Mirror provides for us. So we can say within these curly braces, if has authority, meaning if I did this, if client A did this, card.transform.setParent player area dot transform and change, and we say false as we did before. We want it to inherit its transform location from the player area. else card.transform.setParent enemy area.transform also false. So if I click the button, that means the network server is spawning this card on my behalf, and I should have authority over it. And if I have authority, and you can look this up in the documentation to read further, I want to set its parent to the player area. If I don't, that means someone else clicked the button, and we should set the parent of it to the enemy area. We're just missing one little reference here. We need to call right here, after each card is spawned, we need to call RPC show card and then pass in the card and say that it was just dealt. Okay, so that's that. And we haven't specified what happens when a card is played. We'll do that in a later video. Go back to my scene, let it compile. As a shortcut, I can just hit Control B to build the game in the same directory as I did before. And as I mentioned in a couple episodes, we'll see how to work around this so that it's a bit more simple in terms of workflow. But right now this will do for us. And so in the built version of the game, well, I'm going to run that as a client. That'll be you. You'll be client B. In the editor version of the game, when I hit play, I'm going to act as a host. And then we'll have to wait till the host is started. Then we can run the client. The second client, so you're client B, I'm client A. I'm going to hit draw cards on the host, and now they show up in your scene as in the enemy area, because the mirror has determined that you don't have authority over these cards, and that's why they show up here. Now you hit draw cards, and because you do have authority over those cards, they show up in your player area. And if we go back to client A, being played by me, you can see that I have these two blue cards, then a magenta card, and two blue cards, just as you do. They show up here. So that just lets us know that it's operating correctly. It's not very user-friendly just yet because I can see your cards, and probably in a real-life scenario, you don't want me to be able to see them. And when I drag and drop my card, it looks great in my scene, but it's not sending a message to the server so that you can see it. You just see this mess up here. And when you drag and drop, I see a mess up here too. Like, it's just not, that part of it isn't working because we haven't told Unity and Mirror what we want to do yet. But we will, starting in the next video. So I hope this video has been helpful for you. If it has, please be sure to like it and subscribe to my channel for more. You can also follow me on Twitter, and I'd love for you to check out my books and games as well. You can do so by going to www.nightpathpub.com, or just follow the link that I've included in the description, and we'll see you soon.